Hey YouTube, it's JP Dillon. Welcome to part 2 of the 1959 Philco Predicta Princess service and restoration. In the last video, we were able to go through the set and power it up and validate that we had high voltage and sweep, but there was no vertical sweep. We just had a line across the screen. So before we go too much further, we want to validate that the vertical output transformer is good and the set is capable of producing a vertical sweep, because the two crucial things, first and foremost being the horizontal sweep and then vertical sweep, are important in order to get a picture on the screen. So if we come over here, this guy right here, this is your vertical output transformer, and there's a primary that runs through the vertical output tube, or excuse me, that might be the audio output. I believe this is, this is the vertical output tube. So the primary of the transformer comes from B+, and then the output of that primary goes to the plate on the vertical output tube. And so we need to make sure that this circuit's capable of functioning, as well as the vertical oscillator tube, which isn't too far away. I did dust and clean the board up a little bit, although it needs to be thoroughly cleaned before we completely restore it. So that's where we're going to start, is see if the windings on the transformer are alive. So this is the secondary winding, which goes to the deflection yoke. This is the easiest to measure first. And what we're going to do is just hang our ohm meter across here, because the yoke's not hooked up, so we should only see the secondary of the transformer. Let's see if I can get my probes in the right spot. And we have resistance there at the secondary. So that's about right for a vertical output, about 2 to 5 ohms. So the secondary is good. The primary is a little trickier to get at, because the primary is underneath this here. It's coming out the bottom. I don't know if you can see it or not, but we'll take the transformer up and you can better see where the wires go. But then we're going to ohm out between the B line and the output, which then goes to the plate of the output tube. So with a 1/4-inch nut driver, you just take up the retaining nut here, and then you can lift this up and out of the way enough to where you should be able to get to the side that we need to get to. This evidently does not want to come out of its hole, and so now we can kind of lift up and away. And of course it's going to fight me. Alright, so here's our output transformer, and you can see the bottom side is our primary. And so the primary goes to that pin there, which is the plate pin on the vertical output tube. And if we follow this red lead, have to give it a little tug, it should attach somewhere back here at the B+ line, which should be this guy here. Let's just move stuff aside and we can absolutely validate that that's the correct line by giving a tug on it. And so that's it right there. You can see it moving. So this point here, that's B+. So if we measure between here and that plate connection there, we should be able to see a resistance of the primary. So if we clip between there and our plate, we can see we have a resistance of about 407 ohms. Now this just tells you that the winding is there. You can compare with the schematic and see what it's supposed to be. Usually the SAMs will have a resistance measurement, but that's about what you expect to see. That doesn't tell you if there's an intermittent short or a breakdown in the insulation. That just tells you that the transformer, from the standpoint of the circuit, is in the circuit and it's alive. So obviously the next major failure we see is that capacitor there that's split open. That definitely is probably, well, it's likely in the plate or the cathode circuit, but anyway, that needs to go. That couplet's been replaced. That's still original, it appears. We're going to test these for basic shorts and make sure that there's no short circuits. Obviously that cap's going to go. You can see someone's replaced that there previously. But my goal here is to get basic vertical functionality before I proceed any further. Now we could also have a defect in one of the controls here that does height or linearity. The vertical hold control on this stack could be messed up. All of that, in addition to the dead capacitor, would stop the vertical output from working. So we're just going to do a little bit of basic troubleshooting and make sure that the potentiometers and necessary components are alive, and we'll take measurements there on these adjacent resistors and make sure none of them are open. And the 6DR7, I believe, is a combo oscillator and output tube. We're going to double check that real quick and then look at the pinout and see what components might be involved in keeping this from running. Yeah, so the 6DR7, as I thought, is a dual purpose. It's a vertical deflection amplifier and oscillator, as we can see there. And you've got two triodes there. So one of those is going to be an oscillator, one of those is going to be an output. We're going to check the obvious first, which is the tube alive? And for that, of course, we whip out the handy B&K 747B. So let's look up what a 6DR7 is supposed to be configured as. Okay, so it looks like plate is 64, socket 29, F space EAB space C, DA. Okay, looks good for our first section. So let's go ahead and plug it in and see what happens. Now, it doesn't tell you whether this would be the oscillator section or the vertical output section. But either way, we're going to find out whether this section is good or not. No shorts. Got good emission. Okay, so that's a good thing. And then the second one, the second section here, plate's 94, and we move a couple of switches around. Okay, so we got that reconfigured. And let's check again here. No shorts, no grid emission failure, and usable emission there. That's definitely good enough to produce a picture or a sweep. So we know the tube's good, the output transformer's good. Let's replace the bad cap, and then we'll check our controls. So we're definitely going to clip this guy out of here. And this is just going to be for troubleshooting purposes, so this isn't a permanent fixture. But Black Beauty's definitely got to go. Alright, so you're out. That's just lovely looking. Wonder what it actually measures. So even on the DMM, it's charging. It's about a 13 meg resistor. The fact that it's even reading at all definitely is not good, so that's why we're changing it. Okay, so we just got that bad boy tack soldered in there for now for the purpose of troubleshooting. Eventually, once we validate this is capable of producing sweep, we'll yank this board and we'll clean it up and repopulate it with new sockets and caps and things. But right now, I'm really just concerned about getting vertical sweep on the picture. So the next thing we're going to do is ohm out the vertical hold control, because if it opens, there's nothing to control the oscillator, and oscillator goes away. And then there's also, I believe, a height and linearity control back there that also need to be measured and made sure to work. And then once we get to that point where we validated that all that stuff is capable of functioning, Then we can go back to testing to see if there's sweep or not. So on the control panel at top, the middle one is the vertical hold, and we're just going to rotate that and see if we get consistent reading here. It looks like we do. Actually pretty smooth. Wasn't expecting that to work so well. I mean, we got a little bit of touchiness up here, but a little bit of spritz of CRC should clean that up. And we'll just work it a bit. So now it's pretty smooth. Highest is 70K, and then the lowest looks like down to 0. So I guess we'll set it for about midpoint. And then back here, that's the width. I think that's the vertical linearity right there, and the height is down below, I'm pretty sure. Let's double check on the rear panel. Yeah, so the fat one's the width, which is controlling your screen voltage. The little wire wound next to it's the linearity, and the one down below is the height. Not sure what this empty one here is, but let's ohm those guys out too. Okay, so we've got the linearity pot hooked up. It looks like about 600K at this point. Let me get an adjustment tool in the back here and see if I can adjust it up or down. That one's really touchy. So it looks like we go between 1K and 200 ohms. Of course, that's very erratic and it doesn't really attenuate much, so this control could be bad. Hard to say. Just know that we don't have the full range. Again, I'm going to try and clean it up some. And we'll work this back and forth and see if we get a better. Yeah, that bottom end of the control, it's getting a little better, a little bit lower. But I suspect that I'm supposed to be pretty close to 0 there. Although I don't think that would stop it from working. Probably just couldn't reach full height. Since it's a wire wound, a little bit of deoxit and feeder lube will help it a bit. Sure does make it turn a lot better. Yeah, so it wants to top out at about 170 ohms on the bottom side and 1.4 on the top side. So we'll just set that again at about the halfway mark. It's only a half turn control too, which is interesting. Okay, well, non-linear. All right, and these are the controls. One of these, this is one down here, this is the vertical height. These are the ones that like to get tin whiskers. So that could be fun. Let's light that up for you. Yeah, so we got that one down there. So it looks like the center and the low tap are tied together. And then the high tap, let's trace out where that goes real quick. Can't see with all this muck in the way. Yeah, hard to say where that goes. But we do have a nice little post there I can clip on to. And then we'll use our probe for the center. And see what that looks like. See, that looks like a dead short, so maybe he's got the control cranked all the way up. Be nice if I could. Come on. There we go. Let's wedge that in there. And then let's see if adjusting our control. Assuming I can get the tool in there. Well, look at that. I just touched that thing. Yeah, it's interesting. Well, let's turn this off so we don't have the glare of the light in the way. Trying to get my screwdriver in there. Maybe I'm measuring wrong. So I'm turning this control, and I'm pretty sure I'm measuring from the correct spots there. Yeah, I'm measuring from the center tap and the high side. Oh, I know why. I'm being stupid. Okay, it helps to actually attach it to the correct points. I was literally just reading across the same point. So now let's see if I can adjust this up or down in a meaningful manner. So that's 2.5 on the high side and 81 there. It's pretty touchy. Don't know if that's Tin Whisker Town or if that's something else going on there, but 2.5 megs, that seems a little bit high, but and then we've got like this little spot here where we go between 1 meg and not very much. So I definitely want to clean this control up some. Be nice if I could see what I'm doing, but okay, so let me clean this real quick and then we'll take a new measurement. Well, that produces a little bit smoother of a control action. I've got it turned up to about 3/4 of the way to full. And we still may not have vertical deflection. Now, one thing I learned from another older TV tech who was nice enough to divulge this information, that you can narrow it down between the oscillator section being the culprit and the output section being the culprit by taking a 0.1 microfarad capacitor of rated value of at least 1,000 volts because of the pulses, and you go between the heater line and the grid of the output tube. And so what you're doing is you're using the 60 cycles at 6 volts to stimulate the grid of the output tube, which then, if the output stage is working, should produce deflection. So another handy tip from people of yesteryear that were in this a long time. So what I want to do is figure out what pin the grid is and definitely replace the grid coupling capacitor, which could be incorrectly biasing it. There's also a plate decoupler here, which could also be bad. Just let's do a quick test here. Like that plate decoupling cap measures 136K. That should be fairly high, and this is probably the grid coupler. And that's only measuring 71, but that's of course in circuit, so you can't really be trusting of that. So it may be for the, that's pretty trippy how it's messing with the image stability. It could be that the way to deal with this is to just replace the remaining capacitors in the vertical circuit, just enough to test it, and then power it on and see what happens. And with any luck, we'll have enough deflection. There is couplets for the vertical that can fail, but they usually don't cause a complete loss of sweep. It's usually just bad vertical sync pulses, rolling, distortions, but you never know. It's going to have to get replaced anyways. But at worst, I suppose I can do the old serviceman's trick and get a signal onto the grid and see what it does from there. So, but that's where we're at so far, is that everything should be in line for a test. So I think that's maybe what we'll do next, is put the tube in it and just do some testing once we find out where the grid pin is. And unit 1 apparently is the amplifier section, since it takes the higher voltage. So we're going to look for pin 7. Pin 7 is the grid of unit 1. So 6, 7, 8, and 9, that's the output section, whereas 1 through 5 is the oscillator section. So if we're counting it properly, this would be your pin 1, 2, 3, 4, and 5, and then 6 is your grid coupler, which is the point 1 we replaced. And then there's another one decoupling that input to ground through this guy, which could be bad too. But that's where we would attach our 60 cycle input to test the output stage. And that small decoupling measures just over 2 megs and rising, so it may or may not be leaky. I don't think it is. But the next step is hook everything up and see if we can get some sort of deflection out of it. Alright, so I've got the chassis set back up. We're going to see if with our tests and poking around, if we can get any kind of vertical deflection. Not really sure what's going to happen at this point, but we'll see. I'll bring the filaments up. It's trying. Yeah, so we got the tiniest little bit of deflection there. So the oscillator's trying. So that tells me that at least we have vertical deflection of some kind. Oscillator's running at the wrong speed and whatnot, but that's a good start. So now we can thoroughly take the set down and apart, and we can pull the board up, and we can replace all the tube sockets, and we can replace the components correctly, change any out of tolerance resistors, couplets, etc. But this at least tells us, because before we had no vertical sweep, it was a thin line. Now we have a tiny little bit of sweep, and it's running at the wrong frequency, so the oscillator's trying. The squealing you heard is the fact that I'm running the HV second anode outside of the box, and it is adjacent to an arc point, so we are getting a little bit of corona. But otherwise, all the necessary troubleshooting has been done, and we can go full steam ahead on this thing and get the board cleaned up and repopulated correctly, and replace all the caps, clean the chassis a little bit, and we should be good. So the next video will involve pulling the board up, and we'll get to work on the process of cleaning the board, taking the sockets out, replacing the sockets, and getting a whole bunch of new components in it. And once we get the board correctly repopulated and new couplets and everything, then we'll power up and see where we're at from there, and then we can proceed with the IF and the tuner. Because at worst, this will get an AV input if the tuner is trash. But I'm more concerned with sweep deflection and getting a full raster on the screen before anything else. So anyways, I hope you guys enjoyed part 2. I think we're at part 2 of the Philco Predicta repair service, and more stuff to come in the future. So thanks for watching.